This is the 2023 statistics question. We're going to need to find a z-score based on a mean of 3.87, standard deviation of 0.36, and we're testing 3.5. Let's do a sketch. So we have our mean of 3.87. So we're testing below the mean here, 3.5. And we were asked, so less than 3.5. So we're looking for it in the tail. So it's going to be a negative z-score. So we can just get the positive one and reverse it around. 3.87 minus 3.5 over 0.36 is going to give me 1.03. So if we find a z-score of 1.03, we have 1.038485. 0.8485. So the tail, which is what we're looking for in here, will be 0.1515. So that's the probability that they score less than 3.5, 15.15%. In part B, we have a random sample, so we're bringing in n here. N is equal to 64. And these guys have a mean of 3.74. And we want a 95% confidence interval, and there's a hypothesis test in the next part, so we'll do it all together. So let's find the interval. We have our standard deviation. We're testing 3.74 against an average of 3.87. So let's see what our confidence interval is first and see does it fit inside this. Does 3.87 fit inside it? So we're going to have 1.96 times sigma over root n. This will be our standard error. So we're going to get 1.96 by 0.36 over the square root of 64. We can write it 8 or root 64. And that's giving me 0.0882. So we're testing 3.74. We're going to add on 0.0882, and we'll have to take it away as well to find the interval, 0.0882. So my range of values at the high end, 3.8282, and at the lower end, 3.6518. So my range of values here, my average is going to be between, at the higher end, I'll just write 3.82, at the lower end, 3.65. We can see here 3.87 doesn't fit inside this, so when we're doing our hypothesis testing, we're going to link back to this confidence interval. So we're going to state mean is equal to 3.87. The alternative hypothesis is that the mean has changed, or the mean is not equal to 3.87. The conclusion I would have here is from CI above, from the confidence interval above, 3.87 is greater than the higher end that we had, which was 3.82. Therefore, significant evidence to suggest that whatever we were dealing with, it doesn't matter what the question is about. In this case, it's the average in Galway. The average in Galway is different. You guys have done loads of these at this point, and it's the easiest question on the test. So on to the next part. The next part is pretty word heavy. If you don't like reading all of this information, then you're not in luck, but there's only a little kind of tiny piece of information given, even though there's a lot of words. 80% play the game each day. 90% who win the game play it again the following day. And 25% who do not win the game play it again the following day. And we're given a tree diagram to fill in based on 360,000 people playing. And here's my tree diagram. So it's just kind of basic maths here. We're getting 80% of 360,000. which is 288,000. But you can see the size of the box here. I can't fit 288,000 in there, so I'm just going to write it above. That would leave 72,000. 0.2 of 360. 72,000 are going to lose. Of the 288,000, 90% of them will play again the next day, which is 259,200. They will play, that's in there. And of those that play the game, 80% will win, 20% will lose, and 80% of 259,200 is 207,360. And 20% is given to us. Just double check that 20% of 259,200 is in fact 51840 on a calculator. And again, 90% of these guys will play again the next day. 25% that lose will play again the next day. So it's kind of a funny tree diagram in this question. And 90% of 207 works out as 186624. 25% of 51840 is 12,960. So these people have won all 3 days. These have won and lost. And then on the bottom side, it's 25% of 72,000 is 18,000. We'll play it again the next day. 80% of them will win, and this 20% lose. 20% of 18,000 is 3600, twice 1800, which would leave 14400, 14,400. They win. 90% of them play the next day, and 25% of those play. Quarter 3600 is 900, and 90% of 14,400 is again 12,960, like the number above. And then it does ask us a final question here. One person is picked at random from those who played the game in all 3. Find the probability that they lost on the first or the second or both. Okay, well that means the probability that they won all 3 days. Everyone else will fit into a category where they didn't win all 3. So if we do 1 minus the probability of the win-win-win, we should get to our answer. So let's see how many played on all 3 days. These 4 numbers added together. Played on all 3 days, which is, oh, sorry, the probability that the total will be on the bottom. This guy will be on top. Win-win-win. 186624. And the 4 numbers add up to 213,444. Just double checking that. And this is giving me a fraction as an answer. So if I take 1 minus this guy, it'll give me the answer, which is 745 over 5929. And that's the end of the statistics question.